Hi, I'm Patrick Reagan. Wired Networking Part 6, Troubleshooting Common Cabling Issues, will discuss how to isolate cable problems, including looking for loose and improper network cable connections, and to look for and troubleshoot physical damage to network cables. It discusses cable troubleshooting tools, checking for exceeding maximum lengths of cables, poor cable quality, and incorrect cable types. Networking cabling problems can cause all kinds of headaches, from slow internet speeds to intermittent connections to total connection loss. When troubleshooting network cabling issues, you should use the following guidelines. Start with the basics. Check that cables are properly connected and undamaged. Look for indicator lights on network devices, including NIC and switches. No light usually means no connection. Use a cable tester. Basic testers check continuity, shorts, and miswiring. Advanced testers measure signal quality, crosstalk, and cable length. Swap with known good cable. Replace the suspect cable to see if the problem is resolved. This is a quick and easy test. To isolate a bad port, try connecting the cable into another active port. Don't forget to connect to the correct VLAN. Use ping and traceroute or network speed test to access connectivity and speed. High latency or drop packets may suggest cable issues. Use a loopback test, which is useful for diagnosing NIC or port issues. Loopback plugs help isolate the problem. Check for EMI sources. Identify potential EMI sources and reroute cables as necessary. Document and label cables. If you don't seem to be connected to the network where you cannot visit any sites or access any network resources, you should make sure you're connected to the network. For a wired network, make sure the network interface is installed properly. A cable is connected to the computer that leads to the switch. The cable may go to the wall jack, which leads to the wiring room or data center, that is then connected to a switch. A blinking LED light on the network interface in the switch will show network traffic. If the link LED fails to light, it means the physical connection is inaccessible to the network, which is either the network interface on the computer or the network itself. Check the interfacing cables, including swapping each of them if possible. If you do not see the network interface to show in the operating system, make sure the proper drivers is loaded. You would then swap out the cable and network interface if possible. Remember, the network interface is part of the motherboard to check to see if the interface is enabled in the BIOS setup program. Physical damage to network cables, including crushed, bent, frayed, or cut cables, is more common than people think, especially in environments where cables aren't properly secured or protected. Physical damage is often caused by, in office or home environments, physical damage could occur from foot traffic, furniture pinching, cables, pets chewing, or vacuum cleaner snagging them. In industrial or warehouse settings, physical damage may be caused by heavy machinery, forklifts, and harsher conditions. Cable runs exposed without proper conduit are especially vulnerable. In data centers or server rooms, cable problems usually happen because of poor cable management or during hardware upgrades and/or moves. In outdoor installations, problems are caused by installations that do not have weatherproofing, including UV exposure, temperature extremes, moisture, and animal interference. Symptoms include intermittent connections, no connectivity, and slow speeds. To fix physical damage, you'll need to visually inspect cables, test cables with cable testers, and swap cables to determine bad cables, and then replace the damaged cables. Consider using cable covers or conduits for protection. In network and electrical circuits, an open and short refer to two common types of faults that can affect signal transmission, particularly in wired networks. An open occurs when a wire connection is broken, preventing electrical signals from passing through. In networking, this can happen due to a disconnected or cut cable, a damaged connector or improperly crimped RJ45 plug, or a broken or failed solder joint in network hardware. Symptoms include no network connectivity, high packet loss, or intermittent disconnections, or link lights on switches or routers may not turn on. To fix the problem, First, ensure the cables are plugged in securely. Then you'll need to use a cable tester or time domain reflectometer to locate the break, check connectors, and recrimp or replace faulty cables. A short or short circuit occurs when two wires that should be separate make unintended contact, causing an incorrect electrical path. In networking, this can happen due to frayed or pinched cables where the conductors touch, incorrect wiring in an RJ45 connector, or faulty network hardware causing internal shorts. Symptoms include no connectivity or erratic network behavior, overheating in networking equipment, and potential damage to networking devices in severe cases. To troubleshoot and fix, use a cable tester to check for continuity issues, inspect and replace damaged cables, and ensure proper termination and separation of wire pairs and connectors. Both opens and shorts can disrupt a network, so proper cabling management, testing, and maintenance are crucial to preventing connectivity problems. Loose or improper network cable connections are very common, especially in environments where cables are frequently plugged and unplugged or where installations wasn't done carefully. These issues are one of the top causes of intermittent connectivity problems. The cause is when cables not securely plugged into ports or snapped in connectors. Symptoms include devices randomly disconnect, LAN lights not on, and you get network cable unplugged errors. To fix, you need to reseat connectors firmly into ports and listen for a click on RJ45 connectors. If the problem persists, test cable with cable testers or swap with a known good cable. The tools available to help test cables include the following: cable tester, visual fault locator, toner, and loopbacks. A cable tester is a device used in networking to check the integrity and functionality of cables such as Ethernet, RJ45, coaxial, and fiber optics and telephone cables. It helps technicians diagnose issues like wiring faults, continuity problems, or misconfigurations. Type of cables testers include basic continuity tester, which checks if the cable is physically intact and detects open circuits, short circuits, and crossed wires. You can also use a multimeter measuring the resistance, which should measure 0 ohms. However, you'll have to test pin by pin, which is more a complicated process and more time consuming. Wire mapping testers ensures correct pin-to-pin wiring in Ethernet cables and identifies miswiring, such as split pairs and reversed wires. Time domain reflectometers, or TDR testers, are used to measure the length of cables and detect breaks and kinks, tells you how far away the break or kink is, and it identifies impedance mismatches. Network cable certifiers test cables against industry standards such as Cat5e and Cat6 and measure signal quality and transmission performance. PoE testers, or Power over Ethernet testers, checks if a cable can deliver power and data to a PoE device. A visual fault locator, or VFL, is a device used to detect faults in fiber optics cables. It emits a visible red laser light, usually at 650 nanometer wavelength, into the fiber, allowing technicians to visually identify breaks, bends, bad splices, or other faults. The VFL injects a bright red laser into the fiber. If there's a break, bend, or poor connection, light leaks out at the fault point. The technician can see the red light escaping, pinpointing the exact location of the issue. It is used to identify breaks or bending losses in fiber optics cables, checking fiber continuity and verifying proper splicing, and diagnosing faulty connectors and patch panels. It works best for short distance fibers up to 5 kilometers for multimode and up to 3 kilometers for single mode. It cannot detect microscopic defects like high power optical time domain reflectometers can. It's simple and affordable and effective troubleshooting tool used in fiber optics network maintenance and installation. A network toner, also called a tone generator and probe, and fox and hound, is a tool used by network technicians to trace and identify cables in a bundle or through walls. It consists of two parts. Tone generator sends a signal or tone through the cable. Probe or amplifier probe detects the signal and helps locate the cable. The network toner works by the following process. The tone generator connects it to one end of the cable using alligator clips or an RJ45 connector. It sends a distinct audio signal or tone down the cable. The technician moves the probe along the cable or near potential endpoints. When the probe gets close to the correct cable, it picks up and amplifies the tone, helping to locate it. It's used to identify and tracing network Ethernet cables in a server room, locating phone lines in a telecommunications setup, finding coaxial or other low voltage cables hidden in walls or ceilings, and verifying continuity and identifying breaks in non-powered cables. Limitations include it cannot test data transmission quality or speed, and it may pick up interference in noisy environments. A loopback plug is a small device used in networking to test and diagnose network ports, cables, and interfaces. It works by redirecting or looping back the outgoing signal from a network interface back into the input, allowing for self-testing of the connection. The loopback plug works where the plug is inserted into the network port, such as an Ethernet, serial, or fiber optics. It connects the transmit or TX and receive RX pins, creating a closed signal loop. A network device or tester sends data through the connection and expects to receive the same data back. If the return data matches the send data, the port and cable are working properly. Common uses include testing network ports on switches, routers, and computers, troubleshooting connectivity issues such as faulty NICs or bad ports, verifying network cable integrity, and checking serial communication interfaces. Types of loopback plugs include RJ45 loopback plug, which is used for Ethernet port testing, fiber optics loopback adapters, which test fiber optics transceivers, and serial loopback plug, which is used for RS-232, RS-485, or T1 line diagnostics. Loopback plugs are essential tools for network technicians to quickly isolate and diagnose connection issues. Exceeding the maximum length for network cables is a sneaky but critical issue that can cause major headaches, especially in large spaces like offices, warehouses, or campuses. Ethernet Cat5e or Cat6 runs should not exceed 100 meters or 328 feet. This includes 90 meters or 295 feet of solid core permanent cabling in walls and plus 10 meters, 33 feet of patch cables, which is used between the wall jack and PC and the switch. Going over this can cause signal degradation, packet loss, or the network link failing entirely, especially at gigabit speeds or higher. To fix, measure cable lengths and add switches or repeaters if needed to extend runs. Tips: always label cable lengths during installation. Stick to solid core cables for long runs that handle distance better than the stranded patch cables. Test cables before installation in large projects to avoid surprises. Poor cable quality or using the wrong type of network cable is a common but often overlooked issue, especially in environments where people cut costs, use old stock, or mix cable types without realizing the impact. It can lead to slow speeds, connection drops, and failed performance at higher data rates like gigabit or 10 gigabit Ethernet. Physical signs include having cables that have thin wire or lightweight, have no certification markings, or have noisy signal detected by advanced testers. Common mistakes include using Cat5 for gigabit Ethernet, which should be Cat5e or higher, running Cat5e in an environment where Cat6a or fiber is required for 10 gigabit speeds. Using cheap, non-certified cables that don't meet specs, such as using copper-clad aluminum cables that are unreliable. Mixing stranded patch cables in place of solid-state cables for long runs. And using indoor rated cables outdoors, leading to degradation over time. Core size, or multimode versus single mode fiber mismatching in networking, refers to situations where different types of fiber optics cables or connectors are incorrectly combined, leading to signal loss, connection failure, or performance degradation. It's a common culprit in fiber cabling issues. Multimode fiber, or MMF, has a larger core, while single mode fiber, or SMF, has a tiny core. Connecting MMF to SMF or vice versa causes light dispersion or loss. Multimode fiber to single mode fiber, most of the light misses the smaller core, which equals high signal loss. Single mode fiber to multimode fiber, the light enters the larger core but can cause reflections and signal distortion. Results: bad signal, low performance, or no connection. Besides media types, transceivers and cables need to match wavelength and speed. One transceiver is 1 gigabits and the other is 10 gigabits per second. No link will form if they can't auto-negotiate properly. You also have to look at half duplex versus full duplex. Lastly, vendor locking or compatibility, where some switches require vendor-specific transceivers. Using a third-party one without support may cause it to be rejected. Question: you receive a report that Pat, an existing user, is unable to access the network. Pat confirms that he had full access the previous day. The changelog is reviewed and there have been no changes on Pat's computer or any network changes in the last week. You move the connection to adjacent location on the switch and Pat is able to access the network. Which of the following is the most likely cause of this issue? Answer: bad port. Question: you replace the network patch cable with a longer cable. Now the user is no longer connected to the network. You test the patch cable with a tester and confirm the cable is not faulty. Which of the following is the issue with the newly installed cable? Answer: the total cable run exceeds the maximum distance. Question: a fiber patch cable, which was being stored in an unsecured telecommunications closet with janitorial supplies, which damaged and caused an outage. You replace the broken cable with a new cable from a sealed bag. However, this solution did not resolve the outage. Which of the following is the most likely explanation? Answer: dirty optical cables. Question: a user cannot connect to the network, although others in the office are unaffected. You see that the link lights on the NIC are not on. You need to check which switch port the user is connected to, but the cabling is not labeled. Which of the following is the best way for the technician to find where the computer is connected? Answer: use a tone generator to trace the cable. Question: you're troubleshooting an incident regarding a fiber that is connecting two buildings. You suspect a break may have occurred midway along the route. Which of the following tools should you use to verify the point where the break might be located? Answer: OTDR. Question: you are troubleshooting network connectivity from a wall jack. Readings from a multimeter indicate extremely low ohmic values instead of the rated impedance from the switch port. Which of the following is most likely the cause of this issue? Answer: short circuit. For more information, visit these sites. In summary, networking cabling problems can cause all kinds of headaches, from slow internet speeds to intermittent connections to total connection loss. Physical damage to network cables, including crushed, bent, frayed, or cut cables, is more common than people think, especially in environments where cables aren't properly secured or protected. Loose or improper network cable connections are very common, especially in environments where cables are frequently plugged and unplugged or where installations wasn't done carefully. The tools available to help test cables include the following: cable tester, visual fault locator, toner, and loopbacks. Exceeding the maximum length for network cables is sneaky, but critical issues that can cause major headaches, especially in large spaces like offices, warehouses, or campuses. Most Ethernet, including Cat5e and Cat6 runs, should not exceed 100 meters or 328 feet. Poor cable quality or using the wrong type of network cable is a common but often overlooked issue, especially in environments where people cut costs, use old stock, or mix cable types without realizing the impact. Pore size, or multimode versus single mode fiber mismatching in networking, refers to situations where different types of fiber optics cables or connectors are incorrectly combined, leading to signal loss, connection failure, or performance degradation. Thank you for watching this video. The next video will be wired networking, part 7, troubleshooting signal degradation and PoE issues. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.